Let's start. Hello, everyone. So Long's not here today, and I'm going to cover for him for this tutorial only. And this tutorial is going to be about milestone 1. And I will be going through one of the functions that you will need to learn with you. So let's start. So milestone 1, can you stop talking, please? So milestone 1 contains 4 parts. We have the street database library and the street map library. Those are just 2 APIs that you'll need. And you have your main executable and the tester executable. The street database library is the library that we are providing to you. It will contain all of the information you will need, that your program will need, and you cannot modify it. From your main executable and the tester executable, it will be using the street map library that you will need to implement for queries. And your library will need to call the street database library to get all of the information. So to start with your milestone, first thing to read the handout really carefully because it will contain all of the information you need. And you may need at least 1 global variable to pass the performance tests. We believe you will need at least 1 global variable, and if you insist that you don't need it, well, just prove it by passing the performance test. And why is that? Why do we really need a global variable in this case? Yeah.
That's when we need to get the information very quickly. We need to store it in a variable instead of like going back to go for that one level here.
Yeah. So you will be needing, yep. The mic? Okay. I'll be closer to the mic. Yeah, just pick one. So you will be using the containers from the STL to access data really quickly. And breaking the map into parts, here are the data you will be seeing. First, you will be seeing the intersections. And intersections are connected with street segments. Intersections will have an ID, intersection ID, and street segments will have street segment ID. And these IDs are unique between its own type. So intersection will have its own IDs, and street segment will have its own IDs. In your initial file that we provided to you, we have the load map and the close map. So load map, from the comments, you will load your map related data structure. So this is called a questions there. So load map will be called at the beginning of the function, at the beginning of your program once. And close map is called at when you are cleaning up your data structures at the end. So first step for milestone 1, after you get your initial init, initial repo, before changing anything, do a compile and run the tester executable, ECE297 exercise. And what you will see is you will get a lot of error messages saying that there are some functions not defined because we don't have anything there. So what function do we need? Go to m1.h, and this file contains all of the function headers that you will need to implement, along with their descriptions and speed requirements and comments. In this tutorial, we will be writing this one together, find 3 segments of intersection. So then go into your code and create empty functions for all functions in the m1.h header file. And make sure it compiles by make sure you return something if the function asks for something to return. But you don't need to write anything in them, just write empty functions and do it until there are no more build errors with the ECE297 exercise command. After this, you will get a test summary after all of the tests are run. And because all of your functions are empty, you will be failing all of the tests. And here are a summary of the tests that we will run. And your goal for M1 is to fail 0 of the tests. So next, let's just go look at this function that we're going to write together. From the function description, we are going to return a vector of all of the street segments connected to an intersection, given an intersection ID. So now our only input into this function is intersection ID, which means that you will need to go into the library and find the specific intersection and the information about the intersection. So let's then open the street database API.h. This is just part of the street database API.h header file. You can see the street segments are stored in structs. And here are just the information stored in a single street segment. So the first field is the OSM ID. So the OSM ID is a unique ID that's unique globally. So it's unique between all of the cities in the library, all of the intersections, and all of the street segments. So this is a huge integer. Intersection index from and to. This defines the 2 endpoints of the street segment, from and to. A Boolean one way. If it's true, then the street segment is one way road. If it's false, then it's two-way road. Non-curved points means the number of curved points of the street segment. Speed limit is the speed limit, and the street ID is the ID of the street that the street segment belongs to. So now we have 3 indices that we need to care about: the street ID, the intersection ID, and the street segment ID. And when we go into the file, we can see these 3 functions. The first function, get non-intersection street segment. After reading the comments, you can see that it accesses the intersection index, and it returns the number of street segments connected to it. Don't worry if it seems confusing right now. We're going to go into detail about this. Get intersection street segments. This set a segment number and the intersection index, and it will get the specific street segment index. Then street segment info gets street segment info from the street segment index. So this is just a sequence of calls to obtain the street segment itself. The naming convention of the street database API should be consistent. The get means that you are looking up for something. Usually it's O1 time. Non-street intersection is the entity that we are looking at. Street segment is the attribute that we are getting. So we are looking at the intersection and getting the number of street segments. And this naming convention should be the same for all of the functions. So for any intersection, for example, this one, St. George and Galbraith, we have the intersection ID 232 and 3 street segments connected to it, all with different street segment IDs. So first, we will be calling the get non-intersection street segment 232 on this intersection ID. And it will return 3, meaning 3 street segments are connected to it. Then run the get intersection street segment 012 to get the 3 street segment IDs. And at the end, call the get street segment info of the 3 street segment IDs to obtain the actual street segment struct with the data about each segment. And be careful that the intersection index, street segment index, are all integers. So if you accidentally are using an intersection index to get a street segment, your compiler will not error out. So either be really, really sure that you are doing the right thing, or decide a naming convention between all of the group members. For example, the simplest way is to use an _I for intersection ID and _S for street segment ID, for example. But all of your 3 team members need to agree on this. This is just to avoid mixing out all of the indices that you're using. Okay. And now I will ask you to break into teams and try to implement this function. Find street segments of intersection using the brute force way of just calling the 3 functions that I just introduced above. So recall this function, we want to get from an intersection ID, we want to get all of the street segments connected to it. And we're returning a vector of street segment ID. You can just use any text editor or anything and just type. If you want to test it, you can, and you have the initial code set up, you can just go into VNC, into your UG machine and do it there. Depends on you. And let me know if you need the function headers. If you need this one. Yeah. It should be before. Yep. Anyone needs more time? I'll take that as a no and we'll continue. Yeah. So let's continue. So your code will most likely look like this. We do a for loop And we do I equals to 0 to get non-intersection street segment with the intersection ID. And within the for loop, we run the get intersection street segment with I intersection ID and push back into the vector. Then return the vector. Okay. And now with this, let's run the tester again. And in this case, I'm just going to run it with the test containing intersection. And in this case, you'll see that it will pass the functionality test, but fail the performance. So what we need to do to pass the performance? Also in the M1.8 comment, you will have 3 different speed requirements. For high speed requirements, the function must be fast. And it will likely need to require creation of data structures to access data really fast. For moderate, the function is speed tested, but usually you can do it with a more straightforward implementation. And now means that the function is not speed tested. And this function that we just wrote has a high speed requirement, which means that we'll need to look at its complexity. So with this implementation, and assume that the get functions all have O1 times, what is the complexity? Yeah. Okay, and what is K? It's the number of segments. Section. Yeah, come get a chocolate bar. And how can we speed up the function? Speed up the function from OK to O1. Yeah. Yes, global variables. And you create your global variables here, which is a massive hint given by the comment itself. So what data structure can we use for this function? Vector. Yeah. You can get your. Okay. So let's look at the function's inputs and outputs. The input, we will set an integer intersection ID, which ranges from 0 to get non-intersections -1. This is a continuous range. And we have an output of 3 segment IDs in vector of integers. And let's look at the vectors that we have. And for a vector, we can access the objects by using the square bracket. For a list, we're accessing any object by bound, which means from beginning, we abound by input steps and obtain the iterator. For map, we use find. And on order map, it's similar to map. So which data structures can be accessed with an integer intersection ID? We have the vectors and the maps. Yeah. And list is inefficient because it's inefficient. And what can these data structures contain? Anything. And the complexities are as follows. Vector, we can access anything in O1 times, list O(n) times, map O log n, and unordered map O1. Want something that's less complex than O(n). So it's either going to be vector or unordered map. And if we look at the access really carefully, a vector is just a direct memory access. So it's just a single load instruction to memory, and the load instruction will be covered in EC 243 if it's not already. And unordered map needs to first call a hash function and then a direct memory access. So even though they're both O(1)s, unordered map is slightly slower than vector in terms of memory access, because the hash function takes time. So if we can choose between them, and vectors don't have any cons on using vectors, we can just use vector, which is faster in this case. And vectors are indexed using a number which starts at 0 and goes to size -1. If your input number is from 0 to size -1, the vector is the fastest choice. But in other cases, if your input is not an index, so it's not a continuous range between 0 and size -1, such as if we're not looking up with a number, we're looking up with a string, or if we have a really, really large range of indices that most of them are empty, most of them are unused, then that means that if we use vectors, we are wasting memory space. In that case, we should be using unordered map. But in this case, we just use vectors. And because we are returning a vector of 3 segment IDs, the global variable will be a vector of vectors. And let's create this vector and go into load map and populate this global variable. So what this global variable will look like in memory will be, we have a vector of vectors of integers, and each vector will contain integers. So it will look like this. So basically, it will look like a dynamic 2D array. And intersection 1 3 segment IDs will just be accessed by the square bracket 1. And we'll get a vector of integers. And let's break into groups again and try to populate this global variable inside the load map. Okay, anyone needs more time? I'll continue then. So we'll be first loading from the street database API. Then size the global variable to be the number of intersections such that we can access with intersection ID. And do a for loop from 0 to get num intersections to fill in all the intersections. Inside that, do another for loop to populate the inner vector using get num intersection 3 segment with the intersection ID. And get the 3 segments for each intersection and push them into the vector itself. So here is the code to populate the global variable. And what does the final find 3 segments of intersection function will look like? And it's going to be just one line where we're going to just get the vector from your global variable in O1 time. Okay. And if we run the test again, you'll see that the functionality and the performance tests are on path. Just keep in mind that there is a performance test for mode map, but it's going to be a several seconds. So just make sure that it's not too slow, but if it's slow, it's fine. And that's it for today's tutorial. Any questions? If you have any questions, you can comment. Any question in general?